Hi. So in this video, I'm going to show you how to plot and interpret a cumulative frequency graph. In our first example, we're told that 60 students participated in a long-distance cycling event, and their finishing times are recorded and are shown in this table. For part A, we've been asked to draw a cumulative frequency diagram of the results. So the word cumulative means a running total, and cumulative frequency means the running total of the frequency. So what we do is we plot the upper limit of the time, in this case 0.5, against the frequency up until that point, which you can see in this case is 0. And we carry this on through the rest of our table. So now we're looking at the total number of students who had a finishing time of less than 1 hour, which you can see is still 0. And then the number of students who had a finishing time of less than 1.5 hours will be all of these, which is 5. And then the number of students who had a finishing time of less than 2 hours would be these 5 who finished in less than 1.5 and these 30. So our running total now is for 5 plus this 30. So we get 35. And then we look at the number of runners who finish in less than 2.5 hours, which will be the 5, the 30, and the 17. So this will be 52. And then the total number of runners who finished in less than 3 hours, which will be including the 6. So the cumulative frequency will be 58. And then the number who finished in less than 3.5, that includes the 2, which is our entire sample. So this will be 60. So to plot the graph, what we do is we plot this upper limit against the cumulative frequency. So we'll plot t is 0.5 and the cumulative frequency is 0. So that will go about here. Then we'll have t is 1 and the cumulative frequency again is 0. Then we'll plot 1.5 and 5, 2 and 35, 2.5 against 52, the 3 against 58, and the 3.5 against the 60. And then to plot our graph, we need to draw a smooth curve passing through each of these points. So something like this. So that's part A. For part B, use your diagram to estimate the approximate median finishing time. So another median is the middle value when the data is in order. Our data is in order because the time goes from 0 to 3.5. So if there were 60 students, then the middle person will be the 30th. So what we do is we draw a line from a cumulative frequency of 30 to the curve, and then down from the curve to the horizontal axis. So it looks something like this. Then we can read off this value. So the median finishing time is about 1.9 hours. And we can convert this into hours and minutes. We'll have 1 hour, and 0.9 of an hour is 0.9 times 60, which is plus 54 minutes. Okay? Let's try another question. Okay, so in this question, we're told that the cumulative frequency table gives the ages of 100 people, and we're asked to draw a cumulative frequency graph of this table, and then to estimate the median age, and then to work out an estimate for the number of people older than 55. So perhaps you want to try this question yourself. If you go to my website and download the link, you'll get this PDF. You can pause the video, and when you come back, we'll go through the solution. Okay, so welcome back. So we need to work out our first cumulative frequency, and you can see that 8 people of an age less than or equal to 30. So we'll put an 8 here. And then a further 14 people of an age less than or equal to 40. So we'll add these two together, and we'll get the cumulative frequency of 22. And then for those who are less than or equal to 50, we'll add for 24, and we'll get 46. 60 or younger, we'll add for 34, we'll get a cumulative frequency of 80, and 70 or below, we'll add for 20, and we'll get 100. And then we need to plot the age against the cumulative frequency on this grid. So we'll plot 30 across and 8 up. And that will go about here. And then age is 40, cumulative frequency of 22. An age of 50 or below, and a cumulative frequency of 46. We'll plot 60 against 80, and 70 against 100. Then we'll draw a smooth curve passing through each of these coordinates. So a curve should look something like this. And then for part B, estimate the median age. Well, we know the data is in order, and there's 100 people, so we want the 50th person. So we'll draw a horizontal line across from 50 to the curve, and then we'll go down to the horizontal axis and we'll get our age. And you can see this is about 50 years old. And then for part C, work out an estimate for the number of people older than 55. So now we need to go from an age of 55 up to our curve, and then from our curve we can find the number of people. So all of these people are older than 55. In terms of a frequency, that will be from this point up to our maximum. So this will be 10, 20, 30, 35 people. So we'll say 35 people are older than 55 years old. Okay? Let's try one more question. So finally, this is a problem-solving question, which is coming up more now in exam papers. We're told that a cumulative frequency graph shows information about the marks scored by a group of 120 students, and the ratio of a number of students who failed the test to those who passed is 3 to 5. We've been asked to find the minimum mark needed to pass the test. So again, perhaps you want to try this question yourself. You can pause the video, and when you come back, you can check your solution against mine. Okay, so we know there's 120 students, and the total share between those who failed and passed is 8. So we can work out the value of one share as 120 divided by 8, which is 15. So the ratio of those who failed to those who passed for our 120 students is the 3 times the 15 and the 5 times the 15. So we can see that 45 students failed. So to work out the number of marks needed to pass, we'll go across from 45 to the curve, and then from the curve we'll go down to the horizontal axis. And you can see this is 35 marks. So the minimum mark to pass was 35. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and this PDF from my website, mrmathematics.com. I'll leave a link in the description below.